Hello, it's James here. This is part 6 of OpenDog, the open source dog robot. Check out the previous episodes for some of the prototyping and design. Last 2 episodes we've actually got CNC aluminium parts cut in 6 and 4mm plate, lots of 3D printed parts, and we've done the main assembly. Check out the last video to see what all of this is and what the actuators are. This is a truly open source project, so it's completely open source. The files are in the link below and I'm publishing them as I go, and that means you can commercialize it or modify it and commercialize it as long as you publish a source. This time we're going to be looking at that leg again, which we prototyped before, and we're going to actually make that properly and hopefully get all 4 legs on. But let's have a closer look. So my legs of course fit on here. We're going to have some 30mm steel tube in these clamps which go all the way through the metal and all the way through the extrusion, and that will make the hip joint of course there. So we need to basically make this leg for real, and that means making lots of these structural parts out of CNC aluminium again. So all of this red 3D printed plates here, these are going to be aluminium, and those are the main structure that actually hold that ball screw and hold the motor onto the extrusion. So here's what we're aiming to make in this episode. Of course we have to make 4 of them, 2 lefts and 2 rights, because it's a dog and it has 4 legs. So the main thing we're going to do here is make this plate, which is now all of those plastic pieces merged. I've made it 6mm, and we're going to cut that out of aluminium with the CNC. There's obviously 2 other plates on the other side that hold the bearings. The other thing I've done here is made this 3D printed bushing, and there's a recess in the aluminium plate for a much bigger bearing at the hip. Obviously at the knee we'll just fit those bearings into the plate, and we'll put nuts on the outside. You'll also notice I've made some design changes around the knee here with this piece, which is both the hinge and the pivot points, and we'll talk about that and the alignment of those and how that affects the inverse kinematic model as we assemble it. So as usual we're using Vectric Aspire to plan our toolpaths here. So these are our pieces, and the white area there represents the piece of aluminium I've got. So of course we've got various different toolpaths and we can run that simulation. So that shows us exactly where it's going to cut. We're going to be clearing these big holes and of course leaving that ledge around the edge for the bearing to rest in there, and then cutting the rest out with a profile cut and leaving some tabs here so the pieces don't fly off. So the one thing I didn't show on video, before I cut these parts I actually did a tolerance test for these bearings. So I cut some scrap here to check my bearings are a really good fit in those recesses. So they are a really good fit, and that's how I got the sizes right for these pieces. So now we'll find of course that these fit really well in here. They're a really good push fit, and those fit in there pretty precisely. Obviously there's a cap on the other side holding this one, but that means most of the load can be taken sideways onto the aluminium. But my parts have come out pretty well. They've got pretty clean edges. I have done some clean up again on these of course to take the tabs off and all of that, but that's pretty good. And of course we've got opposites of these for the other pair of legs. So those are all of my CNC parts. We've got the extrusion ready to bolt everything on, but of course we've got to make some more 3D printed parts. So let's look at those parts, starting with the feet. So I've actually 3D printed these Ninja Flex pieces. And you'll remember I said I was using this yellow, which is 3D Filiprint Premium Yellow, because it's a really good match for the Ninja Flex yellow. So I've made these feet. These are pretty temporary until we decide to put foot pressure sensors or something in the feet. But for now, they'll stop the extrusion getting carved up on concrete, and also stop it cutting holes in my carpet, because it's going to be a heavy robot. And these are of course attached with T-nuts and bolts as the other pieces are. So when we looked at the CAD, I said I'd done something slightly different with the knee joint, and that was to offset the pivot point here and the point here for the bar, in fact, that's going to go across to actually push the joint, and I've offset those from the outside of the lower leg. So looking back at the prototype, you'll remember what I did was offset this joint here so it's in line with the ball screw, and I put a 10mm piece of studding through the extrusion and also through the saddle there that runs on the ball screw. And that meant I had a perfect triangle that made my inverse trigonometry, the inverse kinematic model, very easy to calculate, because there's no weird offsets. So looking back at this again, you notice there is an offset, but what you'll notice is that these holes aren't perfectly parallel. And in fact, if we were to put a straight edge on there, aligning them, you'll find there are a slight slant to the rest of the leg. And that in fact means that this line points all the way to the end of the foot. So in fact, these joints with the foot are all still in a straight line. And this was a suggestion. I need to give credit to Oscar at ODrive, who actually suggested this would be a really good way to do it. So regardless of what the actual mechanical assembly is, we've still got those things in a straight line, and that gives us a triangle back to the upper leg and that pivot point. And you can see that that's true by looking at a sketch line that's also there in the CAD. So as I discussed, we've got these yellow caps, which are 3D pins with another recess in, and they fit neatly over the bearing there. And they will bolt down, of course, with 2 holes so that we can hold those bearings in at the hip joints. So these are our shims, which go in between the extrusion and the ball screw, and it gets exactly the right placement so that when these ride, we can put our V wheels in and those run in the slots on the extrusion. So these again are plastic. These are definitely fine to be plastic because they get compressed by the force of the leg pushing up. These we might have to upgrade to aluminium. Obviously we've got that 10mm that goes in there, which makes the pivot points for those levers that push the lower leg. So we're going to try those in plastic to start with, the same as I did on the other actuators, and if we need to upgrade them in the future, then we can. But before we can assemble it, I need to drill all my holes through. I did attempt to drill them through on the CNC, and most of them have gone through, but not all of them completely, because the drill points actually pointed on the end, so some of the holes have come out a bit small. Also, some of these need to come out to 6mm to hold the ball screw mounts. So here are all the parts laid out. Obviously we've got to go and build 8 actuators because there's 2 per leg, 1 for the hip and 1 for the lower leg. So that's what all of those are for. We've got our V-slot wheels in, so they run nicely in the extrusion. And basically we can start screwing this together now. So these are our pairs of ball screws fixed onto each leg. So we've got one there to drive the hip joint and one to drive the knee joint. And of course we've got these plates with the opposing bearing to fit on there for the hip joint, and the one at the other end for the knee joint. So now we can start assembling the lower leg and getting that lever in and putting that part together. So I've got 2 legs mostly built there, at least that knee joint is in, and all of those push rods are in and everything's bolted up. So that's looking pretty substantial. We've got to build the other 2. We've still got 1 foot printing because they take quite a long time. And then we can start putting the hips onto the body. Right, that's all 4 legs made. So we've still got 1 foot to print, which is missing. That's printing at the moment. And we can actually attach those to the body now. So I've installed 30mm steel tubes, which are about 2mm wall thickness in those. They go all the way through to the clamp on the other side. I've got a little bushing here that fits perfectly into the hip bearings, and I've also got this rod which is for the levers that push the hip there. The only design issue I want to point out is this corner here, which shouldn't really be there. It should be in line with this. So I'm going to cut that off with a hacksaw. It's only supporting the encoder at the back of the motor, so that massive piece of aluminium is a bit excessive anyway, but basically that means as the leg leans in, nothing will hit it. Of course, the other side isn't such an issue because the other motor is upside down. Okay, so that's one leg fitted. Obviously, this is the main shoulder pivot here, and this is where the two rods go, and there are two of them going onto this 10mm. And I was a bit sceptical about whether that 10mm will be strong enough. Obviously, this table's really wobbly, so that's not actually the rods bending, because obviously it might bend, but it can only bend if this bends, and I don't think that's going to bend. Obviously, there's two of these rods holding this in a square, but that remains to be seen, and we're going to do some more discussion about that later in the video. Right, that's two legs on. They seem pretty rigid. It's getting really heavy though, so I'm going to have to put it on the floor now to put the back legs on. Right, so all my four legs are fitted. We've still got motors to fit, of course, two on each leg, but for now, it's, yep, a pretty substantial robot. It feels like about over 30 kilograms, I'd say, so far. At the moment, of course, these legs are in the most crouched position. They don't come up any more than that, and that's purely because the actuators without the motors attached can actually be back driven if you push them hard enough. So I can't actually stand it up at this stage until we get the motors on. Even without any electronics, the motor friction will actually hold those actuators in place. So for now, we'll just have to look at it like this, and next time we'll get the motors on and we can stand it up and pose it in different poses. So let's have a closer look at these pivot points. It seems really counterintuitive just to have this bit of 10mm studding and taking apparently the whole load of the leg there for that lever. But as I said before, I don't think this will bend, because unless this bends, then this can't bend. So that seems to be pretty good. And if I apply quite a lot of force to the top here, you can see there's absolutely no deviation in this, presumably because this doesn't bend. The only thing I will do is tie these two together to stop bending that direction with a nice hub on the outside, and that should be pretty much sorted. If there are any further issues with this, then we'll have to build something out of the top of this pivoting point with a triangle that comes down to hold it, which is something we can do because we've got the rails to bolt onto on the top of that aluminium. One thing that was suggested, and I have considered, was whether this whole chassis should be the other way up, so the motors that we put on last time should actually be on the top here, and that means as the legs move this way, underneath there'll be no clearance issues. At the moment I think that we're pretty good. I've got the legs spaced quite far out, and of course those can move on those 30mm steel tubes, so I think we're going to be alright for now for what we need to do. But there's nothing to stop you building an inverted chassis open dog. The only issue is where you put electronics and so on, which is what's going to happen next time. So at the moment there's a slight gap here which we can move the leg in and out. As I said, I'll put hubs on the outside here to hold them on, and we've still got the legs to be much wider because we've got the motors to fit. We need to put something through there to clamp that on both sides, and just generally something to clamp the legs in place. At the moment, of course, the bearings run against those, between those two bits of plastic there, and not against any of the metal or against any of these pieces, so we can put any spacers butted up to those bushings that we want to put in. So next time, as well as the 8 motors, the 2 on each leg, and the encoders and all the wiring, we need to put in some sort of electronics cage, a battery mount that's going to go in the middle here. What we're probably going to do is take these 2 bits of 2020 and mount those a bit higher here, so we've got some rails at the top to mount more equipment on, sensors in the future and so on, and something to contain the electronics in there as well, so if it does fall over or something falls on it, it doesn't smash all the O drives up. And remember, we do have 6 O drives and a number of Arduinos to fit, so there'll probably be 3 at each end. Alright, that's all for this time. Don't forget to check back next time to see us put the motors on and put the electronics in, and look at all of that wiring. Obviously there's still several episodes after that to get the coding to get this up and running. Also, thanks to patrons who support my projects, including this one. Have a look at patreon.com/xrobots and you can get access to some exclusive rewards, including a live stream with me and all my videos and other sneak peeks and pictures early. And of course, this is open source, so don't forget to check out the links in the description if you want to get hold of the CAD and code and the CAD and code for previous episodes. Alright, that's all for now.